Hey guys, it's Marco, and today I'd like to talk to you about how to use the new tool setter in conjunction with the probe and the puck to actually run a program compiled from Fusion 360, and in the process show you how I figure out how to use this device. First though, I just want to show you how it is mounted. So obviously I've drilled 2 holes here on the base. Those are M6 I believe, and bolted it to the plate here. And as far as the cable is concerned, I drill a hole through here, tapped it, that goes all the way through, and then I used, let's see if I can show you, a cable holder. And again, this is let's see if you know, you're able to move it a little bit as necessary, but I wanted to have that cable holder so that when I back all the way up against the wall there, we're not going to have any trouble catching up on that lip, which I was having a problem. So as far as the routing is concerned, it goes out with the rest of the wires, comes out here and goes, it's wired right in the box there. Now I have modified this wiring, just don't want to, there were too many wires going into little connectors there, so I kind of broke them out here, but the concept is still the same that I put in a video on Facebook. I will link to that below, so you'll know exactly how to wire this device. But first I wanted to thank a couple of guys that have made this possible. I've been able to get to this point because of their work. And first is Twin Crest Innovation. He put a video not too long ago on YouTube that is fantastic. It got me most of the way to where I'm trying to go today. And again, I will link it below. So I want to thank him, that got me going in the right direction. And obviously the script that Mike Jr. 83 wrote in GitHub, I certainly used all of those to make this possible. So a great thank to the both of them, and then I will show you how I use them to actually make this machine cut apart. Now the part that we'll be cutting, well, not really cutting, but I have this test piece that I done a little while ago, and what I'm planning on doing is zero out on this corner and pretend we're facing off this top surface, just 50,000 above the deck here, so we don't ruin this piece. Okay, but before we go that far, there are a few things that we need to change in Mach 3 to make this work. First thing, you have to, if you want to use that tool setter, you have to go into config, general config, and here on the tool change right up here, you need to change from ignore tool change to stop spindle and wait for cycle start. That's first thing that you have to change. The other thing that you have to do, let's see, you have to, and you'll see in the Twin Crest Innovation video, you have to import the m6 start.m1s file and m6 end.m1s file. Again, those are written by Mike Jr. They are the files in GitHub. One of the problems I was having is that I couldn't actually edit those, because you're gonna have to get in them and edit them. And I saw Twin Crest was using Notepad. Well, that didn't work for me, so I found out that you can actually edit those with the VB script, Visual Basic Script Editor. And so if we go there and open up, they're both very similar. It starts with a start. You're able to edit at will. So what you need to do, again, and the Twin Crest Innovation shows all that, you need to change these positions. One is a tool change position, where you want to have the machine when you change a tool, and one is the tool setter, where the tool setter is physically located in machine coordinates on your table. Once you change that, then you can save it. I don't need to save it right now. I want to show you. Oops, no. I want to show you the other one. It's very similar. Do the script editor, open. We'll do the end one. Again, you have to scroll down to where it says adjust the following according to your machine. Put whatever numbers you want over there, and that is done. You put those in the Mach 3 directory under macros and the name of your machine. And obviously override the other ones. Let's see. Now, as far as the set tool height here, the script that is in the GitHub is basically the same, identical script that Sharif provides, and you need to go obviously in there at some point with the edit button script. It's not the VB script, but the edit button script, and change your ProPuck height. Mine is 19045. Yours might be a little bit different. Again, I machined the top and the bottom of my puck to make it a little more consistent. So yours obviously going to be a little bit different. I don't know what I just did there. I don't know what path is generating, but we'll get back to that in a minute. Now, one other thing that you need to be careful about, and that cause untold ass pain, sorry, excuse my language today, was the fact that I'm usually work in inches. All my stuff is in inches, but obviously the DMC2 is everything's in millimeter. So I was having a problem, and then when I was telling it to go somewhere, it would just shoot like it was always running into the limits. And what I found out is that what you have to do, and in a post process, you have to, I used to have this in document units, and what you really want to have, you want to have it in millimeters if your machine is in millimeters, and that will generate a G21 instead of a G20, which puts the machine in millimeters, the program in millimeters versus inches. Yeah, if you're having some random issues, double check that value. So the program I'm trying to run here, as I said, is we're gonna have an operation like that. It's gonna zigzag a couple of times, pretend that we're doing a facing. Again, we'll do it above the plane here, about 50,000 above the plane, so we don't run into anything. And same thing with this one. Let's see if you can see. We changed tool. We changed from a 6mm tool to a 12mm tool. Again, the tool doesn't matter to the DMC. As far as the script are concerned, you have to leave the tool set at tool 0. So what I want to show you is that even though the Gcode that this machine puts out, this Fusion 360 puts out, it's got a T6M6 for the tool number 6, and then later we go down, we have a T12M6 right down here. In the Mach 3, we leave it as set at tool 0. It's always set at tool 0. Now, what I did here, just to show you, to make it a little more dramatic and show you that the tool, the machine has calculated the tool length difference, I added, after the tool change, this section where we go G0, X0, Y0, Z0. It goes really fast all the way to the 0 point. And obviously, if that tool length correction has not gone well, you're gonna crash the machine. But I am pretty confident that it won't crash. Let's see. So it does is a little cutting, and then it gets here again, T12M6. Added the same thing, same section, so it will zoom to Z0, Y0, X0. It will show you that even though the tool length has changed, the 0 point is still the same, and we'll do a pretend cut here, and then we're done. Okay, so obviously the first thing we're going to do is reference all axes. Very well. So now the next thing we want to do is go pick up this corner that we're going to call X0, Y0, and not quite yet Z0. We'll get there in a minute with a different system. All right, let's see if we can show you that. All right, I'm going to jog the 2 setter all the way there. And what we're trying to do is put it right over the top of the corner that we're trying to measure, more or less. Let's see, get a little bit less Y here. Yeah, I think that'll be good enough. All right, with that done, we are going to switch over here to the probing routine, and that's the corner we want to measure. So we're going to hit that. It's going to ask us if we plugged in the probe. Probe is plugged in, and we're going to run it. It's going to go touch once, go back, touch again at a slower speed. There you go, and it's going to park itself at a X0, Y0 location. Now, it's important that when you do this, you have auto 0, XY, so that it will actually zero out your G54 coordinates. All right, now it's time to get rid of this probe, and we're going to use the hockey puck with the tool that we'll be theoretically using to set the Z0 up here. So in the interest of brevity, I have already changed the probe to a 6mm end mill, and we'll move it over the feature that we want to measure the Z. So I'm gonna get it roughly in the middle. Let me see, that's about in the middle right there, and I am going to use my hockey puck for that, and I think, okay, so I will hold it with my two fingers here. I will click set to height, and as the auto 0 XY also selected on the probing screen. All right, so this just told the computer that when it touched, the Z was 19.045, which puts this right at 0 height in the corners. Now if I were to click the button on the main screen here, well actually probing screen, that says go to X0, Y0, Z0, that should go actually right in that corner. So let me click that button right here, and hopefully we don't do any damage. Here we go, that's the scariest button on the machine. All right. That is pretty scary, but you can see the tool is centered in both directions, and we are centering the machine. So now we have that. Let's load up the program. Let's see, close that one, I don't know what that is. Open, and this should be the latest. So we're gonna run it, and we shall observe. First thing we're gonna see that is going to be a little bit awkward, and you could actually delete it if you wanted, was this first tool T6M6. It's really not necessary at the beginning, but I don't like to edit the G-code that is being spit out by Fusion 360, because if you get into the habit one time, you forget it and you're gonna do some damage. So we're just gonna run with it. It's gonna do a pretend tool change. Only lasts about a minute, and it doesn't do anything weird. All right. So you can see what's happening now. The spindle is moving over the location of the tool setter that we have recorded in the M6 start.m1s, and is probing the length of this tool. Now you're seeing that in nowhere on the computer or anywhere I have recorded the height of this tool setter. That is irrelevant for what we're trying to do. And so there's no need to measure it or anything like that. Now I have my tool change position set out here away from the part that I would be actually machining right there. Just give me a little more room in case I got a long tool. I don't want to hit something. So I'll be changing the tool here. Again, this is the first one is like not necessary, but I'm gonna click cycle start, and it'll do exactly the same thing and go to a slightly different location afterward. Now inserting some M1s, so it's optional. They're optional stops, so it won't go directly toward the part that we're trying to work. Gives me a little time to talk to you about what's going on. So again, it does exactly the same thing. Down here, it will show the difference between the two tools, which is difference is 0. And I have the tool move a little bit over to the side because I would like to be able to cover up this probe with this 3D printed part, so it doesn't get completely covered up in chips. But for the time being, we'll leave that off, and we're gonna continue on with the program. Again, now the program is gonna go to G0, X0, Y0, Z0 right here. It's gonna be fairly quick. Hopefully we don't break anything. And I'm gonna click cycle start right now. Man, that's always scary. Okay, so we know the tool length is correct. We're gonna go past that M1 and we're gonna start the pretend cutting. So here you go, cycle start. And again, it's gonna be about 50 thousandths above the height of Z0, so we don't accidentally just cut into a part that's already been finished. So there you go. So that's a little cutting, and now the program is finished. Now it wants to go to change tool. But before it changes tool, it's gonna measure the old tool, let me change the tool to a new tool, and then measure the difference between the two tools. And then we will prove that the tool length is correct, because we'll go back to G0, X0, Y0, Z0 pretty fast. And if the length is not correct, we're gonna crash. All right, this time we're actually gonna change a tool when the tool comes up. Let's see if I can find some other tool in there that I can use. Now the program calls for a 12mm tool. I don't have a 12mm tool. Again, the size doesn't really matter. The important thing is that we do not change the tool 0. We want the tool to remain 0 regardless of what the program calls for. Of course, we're gonna use the correct tool, but we're not gonna change the designation. So let me change that tool and get you back in a sec here. All right, we're back. I've just changed the end mill to a chamfer mill. It's a pretty pointy tool there. We have not had to reprobe X and Y because those have not changed. But now, obviously, the Z is completely off because this tool is different stick out than the one before. So again, we're back here. We're at the beginning of the tool change. We're gonna hit cycle start here. And now the spindle will go over the tool setter again and go probe the new tool and record the difference. We'll be able to look at the difference between the two stick outs, and that part of the code that I added where it goes to X0, Y0, Z0 is still in there, and obviously we hope it didn't make any mistakes, otherwise we're going to scrap a brand new tool. But I just thought it would be very important for you to see that the system works. All right, so that's my cue here to press cycle start. The difference is, let's take a look at it. That's the previous tool, the current tool. The difference is about 5.9 millimeters. And so I'm gonna hit cycle start up here again, and we'll see this tool go to the X0, Y0, Z0 position, hopefully without destroying anything in the process. And that, I would say, is pretty tight. Consider that edge there is chamfered, so it's missing about 20 thousandths there. That's why it doesn't touch it exactly. All right, having said that, now we continue cycle start again, and we do another pretend cut, like this was some kind of end mill. I think this was supposed to be some kind of a face mill, but all right, that's the end of the program, and we're done. So I hope you guys liked it. I hope you got something out of it. This has taken me just about all day to try to get this thing into a system where it works, repeatedly the same way. So now I think I can actually start programming parts and not crash tools again. I will add the links to the wiring of the tool setter down at the bottom, below the video, and it's on Facebook, and I will add the links to the script and to the video that Twin Crest Innovation generously created. Anyway, hope you liked it, and good luck.